last week we were doing some examples with the regression analysis, right? Okay, and we were making the regression equation. So let's say you have this data between density and speed or any two values, okay, and you want to build a regression model for it. Then now remember you have only two values, x and y, okay, x and y. Then this method works, okay, it will give you the equation, it will give you the r square as well, okay. So what do? You take this, okay, go to insert and select this one, okay, insert chart and scatter, okay. I'm recording it only for you, okay. So now you have the data, okay. Then what do? If you click on the graph, you will see this plus icon, okay. If you go to the plus icon, okay, you see the term here with the trend line, okay. You see the term here, trend line, okay. So if you click on the trend line, it will show a line here. It will show a line here, okay. This line comes from the equation which we want. So Excel already calculated the equation and gave you the line. Now I want to see the equation and the r square of the equation, okay. So if when you click on the trend line, the line appears, the equation will not appear, okay. So how do we go to the equation? You can go here, okay, and you can look for more options, okay. So first you do the trend line, then you go in more options of the trend line, okay. So when I go there, now you can see here, first of all, different types of trend lines. We have only done linear, okay. We have only done the linear one, y equals to ax plus b, something like this, okay. So we have only done linear, but you can change the type according to your data, you all know that, okay. Now what do I want? Tell me. R square and equation. You see both these things are here, okay. So you check these two options, it will show you the r square and the equation on the graph, okay. So I click here, I see the equation, okay, and I click here, I see the r square, okay. So you put the data, two columns should be consecutive, number of values should be equal, then you select the data, okay, and then you go to insert and insert a scatter chart, okay. Once you get the scatter chart, you will only see the dots, okay.
What about the lens exam?
What about?
Lens.
Yeah, you have to do it yourself, like I said.
Before I...
Yes.
So we have just do LNK and...
Yeah, you can do the LNK here as well. You can take the natural log here as well, no problem. Okay, so I think I have selected this point. Maybe the values are different. Okay, maybe I selected this point. You see, it is different from the rest. So maybe it's, anyways, just focus on the procedure. Okay. So once you have the scatter plots, then you go to plus, okay, and then you will see the option of what? Trend line. Okay, once you click on the trend line, you will see the line. Okay, and then you go for options, more options in the trend line, and you will see this. Okay, so you can see the equation and the chart. Clear? Clear? I can do the same thing for the log of k. So Excel gives me the option to do log of k as well. Okay, so I will take the log of every number. And now you can plot the graph between u and log of k. Okay, same procedure, but now you have to understand what? That here in this equation, y means u and x means k. Okay, but when you do this, then y means u and x means log of k. Clear? Okay, and then we have the actual equation as well. Log of k, we did the log of k for the Greenberg model. This model. So once you find out the equation, then you find out C and Kj and so on. Okay, just like we did earlier. Okay, so coming back to the topic we were discussing shock waves. Okay, so shock waves happen when? Capacity. Sudden change in the capacity causes a shock wave, and the shock waves can be forward or backward. Okay, there was a small problem here in this equation. Okay, so we had u1 here and u2 here, average speed here, average speed here. We had the density here and density here. Okay, so using them we were trying to calculate the equation for velocity of the shock wave. Okay, so we use the number of vehicles going from here to here and then moving forward. The number of vehicles will go from this to this segment are the same number of vehicles which will move forward, right? The numbers will be same. So number of vehicles which are in this segment are denoted by n1. So n1 equals to velocity into density, meaning flow, multiplied by time. Flow into time gives you number. Flow is vehicles per time, right? So you multiply by time, you get the number. Okay, so n1 equals relative speed of the shock wave multiplied by density, so it becomes flow multiplied by time, it becomes number. Same thing for n2, the number of vehicles which are moving forward from here. And then you made n1 equals to n2. So when you make them equal, you get this equation. Okay, relative speed equals to this. So this is relative speed in section 1, this is relative speed in section 2. Okay, and then you simplify it, uw on one side, everything else on the other side. Okay, this is where the mistake was. So this is now this one. I checked it from an old book as well, and this is the equation which they have. Yeah, I think it's reverse. Obviously in the other projector, all the equations were messed up, so we couldn't see as well. But now I've checked it from the book as well. Okay, and you can confirm it from here. See this one? This is the speed of the shock wave. Okay, so you see it was supposed to be q1 minus q2. q1 minus q2. Okay, so q2 becomes 0 because the signal is red. Okay, so you have q1. If it was q2 minus q1, this would be minus q1. Right? q2 was 0, so it will be minus q1. So it's not minus, so that means equation is correct. To tell you the truth, I don't know from where did I take this. This was my problem. I don't know from where did I take this. The 3-4 slides, I don't know from where did I take it. Anyways, so I had to search. Anyways. Yeah, so we did this derivation, okay. This equation gives you the length of the queue at the end of red phase, okay. This equation gives you this is the time required to do what? Clearance time, okay, to clear the queue, okay. So this equation gives you the time required to clear the queue, and then we have an equation for ST. What is ST? Yeah, the maximum length of the queue, okay. Now, can these two values be different? Can these two values be different? This one and this one. Can these be different? No? No?
Yes, can be.
Why?
I feel like.
No, it can't. That's a tough thing.
You want to ask me, can or not?
He
Don't
reads my
ask
mind.
why.
He reads my mind.
It makes sense.
Yeah. Huh?
It makes sense.
Why?
You have to go with the feeling.
Nothing in traffic makes sense. Okay. You guys use your mind less and read my mind more. Yes. It cannot be.
That can be.
Can be. Why?
Because Q and this one density. Density is upon distance.
No. You see, in this one, you are taking the speed of the shock waves, right? You are taking into account the speed of the forming shock wave and the recovery shock wave, right? We are taking the speed into account of the forming shock wave and the recovery shock wave. Okay? So based upon that, the maximum length of the Q can happen anywhere. Okay? It may happen, let me give you a very obvious example. You have a red signal for 20 seconds. The signal becomes green for 30 seconds. Okay? Now the vehicles have a very long queue. They have a very long queue. Okay? So 30 seconds are not enough for them. 30 seconds are not enough for them to clear completely. Okay? So the maximum length of the queue is not at the end of red phase. It may happen somewhere after that. Because next red phase, there will be more vehicles in the queue. Next red phase, there will be more vehicles in the queue. Okay? So, this number is a constant. If it is red for 20 seconds, these many vehicles are in the queue. That's it. This number is not a constant. Okay? It depends upon the velocity of the forming shock wave and the recovery shock wave. Okay? If the forming shock wave is bigger, it is causing more vehicles to stop, and the recovery shock wave is slower, so the vehicles cannot cross during the red. Okay? So the maximum length of the queue can happen anywhere. Okay? It can happen during green, during yellow, during red, okay, and so on. But normally, in normal traffic situations, the most critical one is this one. Because the exceptional case doesn't happen for too long. The exceptional traffic jam, where just the queue keeps on getting longer and longer with every signal, it does not happen for too long. Okay? If it happens for too long, what do the people do? Huh? Yes. Yeah. Yes. What do the people do? You are coming to the intersection, there is a very long queue in front of you. What do you do?
We use the shoulder.
Use a different route, huh?
Use the shoulder.
Use the shoulder, see? Use the shoulder, use the median. There's so many ways to go. Why go to another highway? Anyways, you see her somewhere? Beware of her. She can go in any direction. Okay. So we're looking at this example. Okay. I think we calculate the numbers, right? Okay.
Negative for everything.
Yeah.
Also the length.
Yeah. Okay. No. Even if you calculate it with the new equation now, calculate it. What was it? We calculated the density as well, right? What was the density? Density was 20?
For K1.
K1, yeah. So K1 is 20. Okay, vehicles per mile. Okay, length of the queue at the end of red phase, how much was it? You have Q1, K1 and KJ. Q1 is this, 1000. K1 is 20, KJ is whatever, 150. It will still be negative, right? So length of the Q, how much? After multiplying with the time, huh? And there is one more thing, which is the conversion. Did we do the conversion? The red is in seconds, and your flow will be in per hour. The flow is per hour, right? And the red is in seconds. So there is a conversion required as well. So 15 multiplied by 3600. What is this? Okay, then it was Q1. Divided by K1 minus Kj, right? So K1 minus Kj. How much is it? Okay, so 15, the timing of red. This is Q1. This is K1. We had the flow and the speed. So from flow and speed, I calculated the density. And 150 jam density is given. How much is it? Yes.
واحد يحسب كنت طالع 3 بوينتس.
قاعد احسب لك مخي بس انا طالع الحين.
3 بوينت شي كان.
Zero point something, right?
0.03.
0.03. Now it's what? What are the units? Because it feels like this. Huh? Hamza, makes sense.
Seems big.
Yeah, 0.03 what? Miles. Okay, because you put what? You put this density in vehicles per mile. Okay, if you want to get a significant number, then convert it to feet. So 5280. So this was 0.03. 0.03 multiplied by 5280. How much?
169.
169 feet.
But it's minus.
Minus. It is length. Minus or plus means anything?
Direction.
Direction,
Yeah. Okay. But that's it.
minus that means
But that's
backward.
Yeah. But that's it.
Not
Okay. So don't be bothered about the sign. When it comes to length, that's 169 feet is the length of the cube. That's it. Clear? Okay. Then we had the maximum Q length and the other one. For that we need the speed of the forming shock wave and the recovery shock wave. Speed of the forming shock wave, the recovery shock wave. Okay. So
شوي بس اشرب كل شوي. شوف واحد.
okay, W13, the forming shock wave, it was Q1 minus Q2 upon K1 minus K2, right? Q1 is 1000. Okay. Q1 is.
Is it Q2 minus Q1?
No, I showed you the new equation, right? This one. This one. It will still result in minus. Believe me, it will still result in minus because I am making changes both sides, numerator and denominator. Okay, so whatever the sign you are having is the same sign, but the equation is this one. This one is correct. Okay, 1000 minus 0, Q1 1000 given. They are coming at flow rate of Q1. Why 0? Because signal became red. Signal becomes red, flow rate is 0. divided by K1 minus K2. K1 20. You calculate it using this flow and speed. Okay, 20 minus K2. K2 is the jam density. Why jam density? When the signal becomes red, vehicles are standing very close to each other. So this is the minimum spacing they are standing at. So their density is jam density, which is 150.
7.7.
This is minus
Yes.
7.7. So that one is vehicles per hour, and this one is vehicles per mile. So this is miles per hour. No conversion required here. Okay, then we had W34, the recovery one. Okay, in the recovery, again, Q1 minus Q2 and K1 minus K2. Okay, Q1 is which one? Now, for the recovery, what is my initial condition? The signal is what?
Red.
Red. It will go from red to green now. Red to green. Okay, so when the signal is red, the flow is how much? 0. When the signal will open, it will become green and the vehicles are already in the queue. Then they go at saturation flow rate.
74.
Saturation flow rate.
2000.
Yes. Again, the same rule which I told you about KJ. Because the vehicles are already very close to each other and they are ready when the signal becomes green. So when they leave, they are very close behind. So their flow rate is higher. Here they were coming randomly. Okay. When they were coming, they were not in the queue. Okay. So you came, the person behind you came after 5 seconds, the person behind him came after 10 seconds, whatever. Here they are already ready in the queue, close behind. So when they leave, they are leaving very close. So their flow rate is higher than the original one. Okay, this is the flow rate at which they were coming. This is the flow rate at which they were leaving. Okay, so it's 2000 and K1. What is my K1 now? Signal is red. 150, the jam density, and 75. Okay, the one which you have at saturation flow rate.
26.7.
Okay, so like I said, the sign will be there. Okay, because I made the changes in both cases. Okay, 7.7, 26.7. So now you can calculate RS and ST.
You need ST.
Both we need. Okay, again remember, the W's are in miles per hour and this is in seconds. Okay, and keep in mind, RS is the time. Now you want the time in what? Seconds or hours? Hours. Hours? You want the queue to get cleared in hours? Seconds, right? Okay. And this one is what?
Distance.
Distance. You want the distance in what? Miles or feet?
Feet.
Feet. Okay. So there are some conversions involved here which are not part of the equation. So you have to be careful when you are putting the values. But it will not make any difference with the signs. Okay. Don't say my answer is this or that because I have minus or minus plus. You see, when the formula changes, it makes changes to everything. Okay. W13 is changed. W34 is also changed. So you can put R in hours here because everything is in miles per hour. When you get the answer, then you convert it back into seconds. And here everything is already in miles. Just convert the R into hours. Okay. And once you have the answer, you can convert ST back into feet.
كلهم فيهم بروجيكتات يعلمون عذاب اوكي ما واحد فيهم بروجيكت بس مو فري بروجيكت.
You joined the group? Huh? No, two people were not good. I told them you can join with them.
Yeah, they can. They join also.
How many are you now? This is what? Answer for what? Which value you want? 1,3 is 7.7.
3, 4.
W13 is 7.7. This one is 26.7. 7.7, 26.7. After I show you the answer, then you will ask for the equation again, right? Yes. 15 seconds. 1-5.
The value speed mile per hour. And the ST, we should convert the second to hour.
What?
For the ST.
ST you calculate it in hours and convert to seconds. Because the speeds are already in miles per hour. W13 and 34 are already in miles per hour.
One
162 what? Which value? Q length? Okay, and RS is?
Without converting. I like per number.
Which numbers? So what are the units? Tell me. Did you convert red time or not?
No. I convert it and I divide by it. So I block 7.7 and 26.7 and 15.
Okay, now divide by 3600.
RS 6.1.
Divide by 3600. Multiply by 5280. Sorry?
238.
No, just keep everything as it is. Sorry?
238.
238. Yeah. I'm just saying because it is. Okay. R is in seconds. Small r is in seconds. You convert it to hours, so you can put it in the equation because these values, W values, are in miles per hour. So R should be in hours. Okay. Once you get the value of ST, it will be in miles because this was miles per hour, miles per hour, miles per hour. So ST will be by default in miles. Okay. So then you multiply by 5280, it becomes in feet. Okay. And this is the answer in feet. Okay, it makes sense. I'm not writing minus with everything because this is the length. Okay, you know length is absolute. Length is absolute. I know that Q is behind. I know. Okay, so you can just put Even if we put minus 238, it will not make much difference. Okay, for this case, again put R in hours. Okay, convert R into hours, then you put it in the equation. Okay, because all these things are in miles per hour. So then you will get the answer in hours and you convert it back to seconds. 6.1. So even if you got the minus here, it doesn't matter. Okay, it doesn't mean anything. Clear? If you got minus 6.1 second, doesn't mean anything. Okay. Okay. Any problem? Yes. Any questions by anyone? This is just conversion of units, okay? Just conversion of units. All things must be in the same units.
لا حولها إلى أول في سكند في سكند حولها إلى أول بعدين تضرب في من ترجعها في
Okay? Should I move forward? Okay. Now we have two types of models. We have the green sheet model and the green bug model. Okay, pay attention now. Just leave it, whatever it is. We have the green bug model and the green sheet model. Okay, we have two models. Okay, the green sheet model is the one with the linear equation. This one. Okay, where US means the space means speed. Okay, UF means what? Free flow speed. KJ means what? And KI is density. Okay. So this is the actual equation we have. Okay, this is the actual equation we have. If you open the bracket, it will become the same equation which we have bright. Okay. So they took UF as a constant outside. Okay, let me show you the actual equation was this one with the UF. This one. Speed was this one. If you take UF outside, then this becomes 1. And this is here K upon Kj. Okay. Now what they are saying is K upon Kj can be represented with a letter eta. Looks like an N. Okay. So the linear equation we had, I took UF as constant outside, common. Okay. So in the bracket we have this. Okay. So this ratio is represented with eta. Okay. What is eta? K upon Kj. What is eta? K upon Kj. Where K is a density, any density, and Kj is the jam density. Clear? Clear? Okay. Now what was the equation of the speed of the shock wave? What is the equation of the speed of the shock wave? Yes. This is the equation, right? Huh? Q is what? Flow, right? Q is flow. Okay. And K is density. Now, flow, which is Q, flow equals density into speed. Remember there was an equation, Q equals Q. Q equals Q.
Q equal Q. Yes, makes sense.
No, Q, this Q, there is Q, there is no Q. Okay. The actual equation was The actual equation was flow equals this. Okay, Q equals K into U. This is what I am saying. Q equals Q. Okay, Q equals Q. This is what I am saying.
Okay.
Now you got it. Huh? Now it makes sense.
Now it makes sense, yeah.
Okay, so I was doing K1 minus K2, right? Q1 minus Q2. Q1 minus Q2. Okay, so instead of Q, I'll put K into
U.
U. Instead of Q, I'll put K into
U.
U. What is my U?
This means
This thing, right? This equation is my U. Okay, or this equation is my
U.
U. So this equation multiplied by K will become
U.
Q.
Got it? So instead of doing Q1 minus Q2, I'll do the equation of U multiplied by
Okay.
K. Got it? Equation of Q multiplied by K. Okay? It was Q1 minus Q2. So equation of U1 multiplied by K1 minus equation of U2 multiplied by K2. Clear? Clear? Okay? This is what they have done here. And I already mentioned that this ratio equals to what? Eta. Okay? This ratio change into eta. Clear? Okay? So this is what they have done up till here, and in the end, okay, you can open these brackets, okay, but after doing all the simplifications and using the eta and everything, in the end you will get this equation. Okay, so according to Greenshield model, the velocity of shock wave equals to this. The velocity of shock wave equals to this. Okay. What is this? Free flow speed. Eta 1 means what? What is eta 1? What was eta?
K1 plus
Yes. So eta 1 means K1 upon Kj. And eta 2 means what?
K2.
K2 upon K. Clear? Clear? You can look at the rest of the steps. All the steps are shown. Again, they are from a book which I don't know which one. Okay, so they are there. Anyways, but the main step was this one. First of all, K upon Kj is represented with eta. And then in the equation of UW, the Q is replaced by K into the equation of U. Okay, these were the two main steps. Other things are simplifications. Okay, since you replaced U with the Greenshield equation, this is the Greenshield equation, right? So the velocity of shock wave equals to this according to Greenshield model. Okay, so it's not a general equation. Okay, general equation was the last one which we solved in the last example. Okay, this equation is according to Greenshield model because you changed the Q value using the Greenshield equation. Got it? Clear? Okay. Now, if the densities are nearly equal, if K1 is almost equal to K2, if K1 is almost equal to K2, that means what?
U equal U.
No.
eta 1.
Eta 1 is almost equal to eta. Because Kj is a constant, right? Jam density is constant. And then we are saying K1 is almost equal to K2. Okay? So if eta 1 equals to eta 2, it becomes what?
2
2 etas. Clear? Okay? So if the initial density and the final density are almost same, then according to Greenshield model, the velocity of the shock wave equals to UF into 1 minus 2 eta 1. Clear? Okay? then if it is a stopping wave, so in a stopping wave what will happen? It will go from green to red. Signal will go from green to red. So what is my K2? Signal was green, now it is red.
Jam density.
Okay, so my K2 equals to
Jam density.
jam density. So eta 2 will become what?
1.
1. Eta was K upon Kj, right?
Yes.
So if your K is equal to Kj, then eta equals to 1. So now what will happen to this equation now? This is 1 and this is also 1. Okay. So they will cancel out and you will at the end have this equation. Okay. So this will happen if the signal turns red. So according to Greenshield model, when the signal turns red, you can calculate the velocity of the shock wave using this. Got it? Okay. And if it is starting wave, okay, if it is starting wave, then the reverse will happen, right? Signal was red. Signal was red. So which density was the jam density?
K2.
K1.
K1.
Signal was already red, so people were already having jam density. So eta 1 will become 1 now. Okay? Eta 1 will become 1. Signal was red, so K1 equals to Kj, jam density. Whenever the signal becomes red, or whenever the signal is red, density equals to
Jam density.
jam density. Here it became red, so K2 equals to jam density. Here it was already red, so K1 becomes equal to jam density. Okay, so whichever it is, then that eta will become 1. Okay, so if you put this as 1 here, then again you get this equation. Okay. Okay, then we know that speed equals to, this was the equation, right? Speed equation. This is my speed equation, right? The original one. Okay, so speed equals to this. If you drive this equation for eta 2, then this is what we have. Okay, the actual equation is this one. US equals UF into 1 minus eta. So if this is US2, then this is
Eta 2.
eta 2. Okay, so using this equation you can get the value of eta 2 here. Okay, which is 1 minus US2 upon UF. Okay, so then you can put this value of eta 2 in this equation. Okay, got it? The value of eta 2 into this, here we have eta 2, right? So eta 2 into minus UF. So we take the value of eta 2 from here and put it here. So the equation will become this. Okay. So this is the equation for velocity of the shock wave when the signal goes from red to green according to Greenshield model. Okay. Now let me summarize what we did. We had the normal Greenshield model. In the normal Greenshield model, we introduced a variable eta. What is eta? K upon. Then we went to the equation of velocity of shock wave. Velocity of shock wave equals Q1 minus Q2 upon K1 minus K. Okay. Q equals density into speed. Okay, and Greenshield gives me the equation of speed. So I replace Q with K into U, and then U with the equation of Greenshield. Okay, so my final equation becomes velocity of the shock wave equals to this whole thing with etas. Okay, so if the final and initial are same, then velocity of the shock wave equals to this. If you have a red signal, it goes from green to red, then then eta 2 will become 1 and you have this final equation. Okay. If it goes from red to green, then eta 1 will become 1 and this is my final equation. In this equation I have eta 2, so I can replace eta 2 from here. Instead of eta 2 I can make it in terms of speed only. So here you can see there is no eta, right? Only speed. This is what? Which is speed? Free flow speed. This is what? Final speed. Okay, so there is no density here. In the final equation there is no density. All of these are according to who? Greenshield. Clear? Okay. Like I said, you can have another look at these equations, especially this derivation, which we did not discuss. Okay, but it's just a simplification of what they have already done.